Alright, this is the example that we worked out in class on Cramer's rule. It was right at the end of class, so you'll probably have notes on it, but I want to work back through it again to make sure everything is very clear. We'll go through a determinant, we'll recover determinants, and then we'll also cover the Cramer's rule to solve a system of two equations. And this system of two equations comes from page 271 in your book. So this is also on page 271 in your book. Also on page 271. It is an example on the bottom of the book, and we'll work through it here to show you how we develop it step by step. So remember when we were talking in class, we introduced a new kind of matrix. That new kind of matrix was called a coefficient matrix. So the first thing we want to do with our system is define our coefficient matrix. Our coefficient matrix. And when we're finding our coefficient matrix, we only want to use the coefficients in our system. So we're not concerned with our constant values out here yet. We've got everything in line, x's, and then y's, and then our equals, and our constants. For our coefficient matrix, we're only concerned with the coefficients of these values. Our coefficient matrix is going to look like this. We're going to have it, and we'll have our A1 coefficient here, and our B1 will be here, that coefficient. Our A2 coefficient comes from our second equation. Our B2 coefficient comes from our second equation. And then we have our C values out here, which we aren't dealing with in our coefficient matrix yet. So our x coefficient in the first equation is 1. And our y coefficient in the first equation is -1. In our second equation, our x coefficient is 2. And in our second equation, our y coefficient is -1 as well. So here we have our coefficient matrix made up of the coefficients from this system. 1, -1, 2, -1. My x and my y coefficient, my x and my y coefficient. Once I have this coefficient matrix, I need to find the determinant of this coefficient matrix. And I'm going to call that determinant D. So D will equal the determinant of my coefficient matrix. And I can represent that with my straight lines on either side. That means take the determinant of this matrix. And remember the way that we take a determinant of a 2 by 2 matrix, right down here, the determinant of a 2 by 2 matrix, I find the cross products, where I go down diagonals first. I go down a diagonal and multiply those elements. So I'll say 1 times -1. If we want, we can keep it in the same colors. Let's put them in the colors. I'm going to have 1 times -1, 1 times -1, and then I'm going to subtract my up diagonal product. So I'll get 2 times -1. And I can simplify this now. I can break it down. We can say that this will equal 1 times -1 is -1. 2 times -1, remember I'm subtracting, 1 times -1 is -1, minus 2 times -1 is -2. And here I have minus a positive, minus a negative becomes a positive. Negative 1 plus 2 is 1. So the determinant of my coefficient matrix, D equals 1. My determinant of the coefficient matrix equals 1. So now I have my D value down here. I'm ready to solve for my X and my Y. Let's come over here and we'll plug in. If we look here, when I'm solving for X, X equals C1, C2, B1, B2. The determinant of that divided by my determinant D. When I want to find X, I replace my X coefficients with the constant coefficients, my C values. So when I want to find X, this is the same thing as my coefficient matrix. I just replaced my X values. Let me move this down a little bit. I replaced my X values with my C values. My C values here are 3 and negative 1. 3, negative 1. My Y values will stay the same. My B values don't change. So I still have negative 1 and negative 1. These are the coefficients for my Y's here. And these are the constant values here, 3 and negative 1. So when I want to find X, I need to replace the X coefficients with the C values. And down here, my D we evaluated was 1. So I'll leave that as a 1. Now I can simplify this. I know how to find the determinant of a 2 by 2 matrix. I simply go 3 times negative 1 minus negative 1 times negative 1. And that's still all over, that's just all over the value of 1. My D value, the determinant of my original coefficient matrix here. 3 times negative 1 is negative 3 minus negative 1 times negative 1 is 1. All over 1. So I have negative 3 minus 1. My X value equals negative 4 over 1. So my X value equals negative 4. Now to find my Y value, I do a very similar process. Using Cramers' rule, I still need the determinant of my coefficient matrix on the bottom. And then on the top, if I'm trying to find Y, I'm going to replace Y coefficients. So I'll keep my A1 and A2, my X coefficients, 1 and 2, and then I will replace my negative 1, my Y coefficients, with my C values, 3 and negative 1. So again, if I'm trying to find Y, I need to replace the Y coefficients. I can simplify that and find the determinant with the wrong symbol there. I need to find the determinant of 1, 3, 2, negative 1. Keep my X coefficients. I'm trying to find Y, so I replace the Y coefficients with my C values. So now Y will equal 1 times negative 1. It's 1 times negative 1. Minus 2 times 3. 2 times 3. All of that will be over my D value, which I got from the determinant of my coefficient matrix. 1 times negative 1 is negative 1. Minus 2 times 3 is 6 over 1. y equals negative 1 minus 6 is negative 7 over 1. Y equals negative 7. My final solution, like with the systems that we solved previously, my final solution to this system should be an ordered pair. So my solution is negative 4, negative 7. And we can plug those back in and find that they do actually work as a solution.